Well, here I am. This is about as far as I can take it given the sensor I have. I've ordered three more sensors, all different ranges, 250, 500, and 1K ohms. This one is at 2K or 12K, I don't know, I forget, but it's way up there, so its sensitivity is not so great. But what I've set this up with is, I believe what I have is a slow RPM motor that is used in the switchers, so it's a little slower speed, and I think that's going to help us try to emulate the TMCC with the speed control. That'll be the next step, but I really want to get the new sensors. But at any rate, with this motor, I'm cruising at 30 miles an hour on the transformer. That's about 10 volts, pulling 1.25 amperes. I'm pumping 7.29 to the, where's that going? I don't know where it's going. I guess it's going to the, to the control board, to the puffer board. 7.9 to the puffer board, and to the regulator, the volt regulator. And the volt regulator is got a heat sink, but it's not warm. Okay. And here's the smoke. So cruising at idle, okay? And if we had a load, and realistically, you're on TMCC, so you could go like really slow, right? You could just get the chuff that way. And you can also see that we still have the stream of smoke in between chuffs with a constant RPM. So this is where we are at low speed. About 5 volts is coming through, and we're at about 110 to 112 degrees C. It actually goes 109 to 112 range. So now we want to crank it up. A couple of things happen. RPMs go up, so the pulse for the fan increases, so we're going to get more pulses. The more pulses, that's the more air cooling off the heater, right? So the temperature is going to have to accommodate that. The other thing is voltage goes up. So when our source voltage goes from 7.3 to 9, our applied voltage can also go up. So what happens, even with the fan going, we have now more voltage, our temperature starts to go up. But I've got it pretty well adjusted where we stick between 110 and 120. It will not go above that. It may climb to about 6 volts, but then it's going to start pulling itself down as the temperature increases. So here we are at 110, 5 volts, 7.2 coming in. I'm going to go full speed, 120. Now we're at 9 volts supplied, available. We're up to 6 volts coming into the circuit, and we're cranking. Well, here, let's see the result of the smoke, right? And we're cranking at 123, 125. But the billow of smoke is pretty substantial, I would say. I did some other things to the service there. Now we're climbing up to 130, 132. We're in danger zone. I don't like this hot zone. And we're at 5.9. We'd like to see that start pulling down. 5.8. Now it's coming back. It's sort of peaking, and now it's coming back down. We hope things are working right. It's puffing like crazy. Air is warm coming through there too, by the way. 5.9. We're at 9.2. We should be pulling it down. Please pull down. I think it will. It did a few minutes ago. I was at 120. As it stabilized, it came back down to 120. Maybe it's not going to. Maybe I've melted through something already and it's just not cooperating. I don't know. Well, there we are. 130, 129, 131, 132. Oh, hell's bells. Well, you get the idea. It will stabilize. It's not going to go to 160, that's for damn sure, which was the danger zone. We're at hopping. See that hopping goes from 5.7 to 4.7 to 1 volt. I don't know. It's trying to do something. I don't know if that's overheating. It's pretty warm over there, so that may be having a problem. I may have to do something about that. I don't know where we are, but we got the good smoke. It's coming down. I don't know if I put it in like cruise mode, let's say 70. Temperatures are still high. We got good smoke. Voltage is, the available voltage is now 8.5. Temperatures around 5.3. Temperatures dropping 129. Well, it was dropping 130. I don't know why it's not dropping. It should be dropping. I had better control 5 minutes ago before I decided to make a video. It's always the case. Well, here's what's going to happen. I'm going to leave this with where it's at with it. Oh, and I went from this stuff, rock wool, to my favorite, angel hair. Okay, I got a tiki lamp and ripped it apart and got the angel hair out of it. Stuffed that in here, and I really like that. Seems to work better for me. Okay, now we're down to 120 and at 540. It took a while, but it got there. So this is where I think we're going to be ending up playing most of the time, in the 120 range. So you'll get a good deal of smoke, but you'll have the opportunity to slow down and speed up, and the smoke won't overwhelm you or disappear. Okay, that's the game plan. The thing I was getting at is I'm on a Lionel controller that Carl fixed for me, and I also have the slow motor, so I can't really go real slow, but I can go pretty slow. The other thing is the next test will be on a TMC board where you're going to get track voltage coming in through a rectifier, so it'll be 9 volts. But that voltage is going to stay the same, and the engine speed is going to go up and down. So you're going to have strong smoke at slow speed using TMCC. So when we talk about getting that puff, you're going to have good smoke. You're going to have good smoke, and you're going to have some ability to demonstrate the puff. Plus, the puff is going to be synchronized with the sound, so your brain will put all that together and it'll work better. That's my opinion. So at slow speeds, we're in the 120s, 530, 8.45 volts. It's all kind of hanging around that zone, so I feel comfortable. We're homing in on it. That's a 10 ohm resistor. I seem to like those. They give me that low speed smoke I like. Also the I won't know the temperature sensors. When I get the new thermistors, I'm going to have to do some calculations and do some math and run them around, see what they do and how they behave. But here you can see it at slow speed. We started to get a little cool down, and the temperature started to go up, and now it's the voltages are starting to come down. And I crank this down to low speed. Let's see what happens at low speed. Temperature's dropping, voltage is dropping, temperature is starting to come down. It takes a while to normalize. You may top 140, but it comes back down pretty quickly to the range we want. So this is at low speed, and you can see what you have now. Yeah, I'm not very good at doing this, but if you had a load and you had your TMCC and you just had it on a little bit, and especially with Cruise Commander, you'll see that, and I'm going to set that up. But the big message of the day was, I think the AC motors work okay. You can do it. They actually run real strong, but for some reason they are the noisiest dogs, and I don't know where the noise is coming from. It's almost as if the batteries are rattling among themselves. I don't know what it is, but it's just there's nothing loose. I've got this second motor. I put this other one in that I converted, and it pulls well as indeed, and yet I don't know. I've got a slower armature coming. Maybe that'll help. It may be that you just can't get there from here. It may be that it's just not going to let you. I don't know, but we built one anyway, and we tried it. I'm just not sure we can make it work in the way we want it to. Nice and quiet, behave itself. So, all right, that's where we are. I've set the AC motors aside, the conversions aside. I've gone to a slow speed S&S, which I think is a good motor. and we've got smoke at all ranges, a good smoke at all ranges, and we're not overheating and causing catastrophe. I've been running this all afternoon, about 4 or 5 hours straight, and it seems to be able to live pretty well. So I think we're homing in on this thing. And the dude, that is really warm right now, so it does not want to run slow when you have that voltage ready. It likes to let that volts through. When you ask it to burn off that energy, that's where it gets hot, I guess. Okay, so there we are, puffing and chuffing, and we'll keep you in touch with what goes on when I start to put in the TMCC system. Okay, later.